And it's working. All right. So we'll go here and here. All right. The 12 basic functions. Okay, 12 basic functions is today. We're going to look at graphs, and most graphs are derived from one of the 12 basic functions. Okay, so we'll take a graph and manipulate it so it looks differently. Okay, so the first basic function, number one, the identity function, f of x equals x. It makes a straight line. Okay, it makes a straight line. So this would include f of x equals 2x, f of x equals 5x minus 1, and so on. Okay, so we can just manipulate this into being all kinds of other graphs, but the basic function is the identity function, f of x equals x, y equals x, 0 equals 0, 1 equals 1, 2 equals 2, so on. Okay, that's the identity function. The second basic function is a squaring function, makes a parabola. Okay, and again, we can put a 2 in front. We can do all kinds of stuff to it to manipulate it, flip it upside down, this and that. Okay, so the parabola is a squaring function, f of x equals x squared. That's our second basic function. Okay. Our third basic function is a cubing function. Okay. So our first one was x to the first power, our second one was x squared, our third one is x cubed. Okay. It's an odd function. So it flips over the x-axis and the y-axis. Its reflection is over both the x-axis and y-axis. So the cubing function, or the cubic function, is our third basic function of all the functions. Okay. The reciprocal function, it makes what's called a hyperbola. And we'll study hyperbolas later this year. But we'll see this one a lot. Okay? We'll see this one a lot. 1 over x. 1 over x is a graph that looks like that. And every one of these we're going to manipulate in one way or another. So that was number 4. Number 5 is the square root function. F of x equals the square root of x. The sixth one is the exponential function. E is Euler's number. It's Euler's number, not Euler. Euler. Name that movie. Ferris Bueller's Day Off. Absolutely. Okay, the exponential function. Okay, that's half of them. We're halfway through all our functions. The natural log function, which is the inverse of the exponential function. They're inverse functions of each other. And then we go to trig. We have the sine function. And then, what do you think is after the sine function? Cosine function. So we're 7 was a natural log. Whoops. 8 was a sine. 9 is a cosine. So those, how many have taken trig? How many have not yet been in trig? Ooh, okay. Yeah, because a couple of you are in trig right now, and we don't get to this until chapter 2. So, but it'll be all right. We'll figure it out. Okay, so cosine function. The absolute value function is number 10. Absolute values always make a V. Might make an upside down V, but it makes. Okay, number 11 is the greatest integer function. You won't hit this one very often, but it's a stair-step function. So that's number 11. And the last one is the logistic function. And that's our fish tank function. Why I call it a fish tank function? Well, you have a certain population and it grows until a point where it levels off. Because my fish tank, like for the number of snails, the number of snails keep reproducing until there gets to be too many snails in there, and then they start dying because that fish tank can only support so many snails. Okay, so that's the logistic function. So those are our 12 basic functions. Okay, so you'll kind of have to know which is which is which a little bit. Okay, you'll have to know which is which is which. Okay, so one of the function has its domain. One of the functions has domain of the set of all real numbers except for 0. So out of these 12 basic functions, which one has a domain of all real numbers except for 0? All real numbers except for 0. Not absolute value. That just has a range that goes somewhere else. But it's this one, the reciprocal function. Because see how it goes really close to 0 here and really close to 0 here, but it never quite hits 0? Okay, so the reciprocal function is the only function that is. Somebody, oh, I wonder if that's my phone or if that's one of your guys' phones. All right. If we look at the function, this function, which basic function does that derive from? The squaring function. Y equals x squared looks like this. When you put a negative in front of the x, what happens to it? It flips down like that. And then this is on the x-axis and x and y intercept. But if it's a -1, this one would go down 1 from it. Okay? So we can take the basic function and figure out what's happening to that. And that's what a lot of today will be. Okay, what function looks like this? So where is it increasing? Well, it's increasing from negative infinity up to 0. And then where is it decreasing? Well, then that is from 0 to infinity. Okay? So it's increasing till it gets to there. It's decreasing after. Is it odd, even, or neither? Well, an odd function reflects across the y-axis and then reflects across the x-axis. An even function just reflects across the y-axis, and that's all. So odd reflects across both y and x axis, and an even just reflects across the y axis. Okay? So, would this be odd, even, or neither? It would be an even function because it just reflects across the y-axis. It's the same thing on each side of the axis. Does it have any extrema? Well, this one right here is what we're looking for. Does it have a maximum or a minimum? Well, right here would be the maximum, right? The maximum would be at 0, -1 would be the max. And then how does it relate to the basic function? Well, it's reflect across the x-axis and translates down 1. Okay? So we just take a function, one of the basic functions, figure out what happened to it, and then we answer questions. All right. So let's go to, and I forgot to do this before we started, so it'll discard the annotations. So give me just a second to bring up the other notes because I forgot to bring them up. I'm going to find them. I'm so stupid. Okay, well, we're already this far into it. Yeah. I was going to do something else today. I was supposed to do something else today. But I totally screwed this today up. That's what happens when you only get 3 hours of sleep. Okay, so what do? I think we got to go in reverse now. Guess what? You just got a preview of what we're doing on Tuesday. Because I forgot to cover 1.2c. So, but that's all right. We need to do 1.2c first, which Okay. So 1.2c is first. 1.2c, I've already talked about a little bit. It's odd and even functions. And some others, but odd and even functions. Now, a little bit ago, we talked about this type of function. What type of function is it? What do we call it? It's our third one, the cubic function. This is a cube function or a cubic function. Okay, so a cubic function, its base function looks like this, correct? Okay, now if you put a 4 onto it, when you multiply one of the basic functions by a number, it just stretches it. So it's going to stretch it vertically. So it's going to make it skinnier. Okay? It's going to make it skinnier. Now, from here to get down to here, what do we do? Well, we reflect across the y-axis, and then we would and it would look like this, and then we reflect it across the x-axis, and it looks like this. So when we reflect, is it an odd or even function? Odd function. It's an odd function. Okay? Now, when you see something like this, you go, geez, I don't know what that is. What you could do is graph it on the graphing calculator and look, or what power is this right here? X to the fourth, right? If you take the square root of x to the fourth, that equals x squared. And then you have another x out front. If you have another x out front, it's like you're multiplying it by x. Now, you could say, well, that makes x cubed. Well, let's look at this on a graphing calculator. If we look at it on a graphing calculator, it is 2x basically times, don't need to put the times in there, but I did, 15 minus x raised to the fourth power. Raised to the fourth power. Okay. Now, looking at that, does that look like an odd function? It flips around the y-axis, then flips around the x-axis, so yes, the function is odd. Okay. Now, you have x to the sixth, x to the second, which are both what types of numbers? Even. But then you mix it in with an odd number. So if you have an even and an odd, it is neither. Okay? When you mix even and odd numbers, if everything is even, then it should be an even function. Okay? If everything is odd, it's an odd function. When you mix, it's not. So, what type of function would this be? It would be an odd function because both the powers are there. Okay, then we'll talk about asymptotes. All right, one of our basic functions is 1 over x, and 1 over x is 0 can't be graphed, 0.11, 2, 1/2. If we put a 2 in here, it's 1/2. If we put a 3 in here, it's 1/3, and so on. If we put a 1/2 in here, 1 over 1/2 is 2, and so on. So it looks like this, and then it looks like this. Okay, that's what 1 over x. So now we have 4x over x minus 3. Okay, so there's going to be an asymptote somewhere, and it all depends on the denominator where the vertical asymptote is at. Okay, the vertical asymptote depends upon the denominator. So you set the denominator, x minus 3, equal to 0 to find the vertical asymptote. Well, how do we get x alone? Add 3. So x equals 3 is our vertical asymptote. So at 1, 2, 3, we're going to have a vertical asymptote going on here. Okay? X equals 3 is the vertical asymptote. Horizontal asymptote, you'll want to write this down. Horizontal asymptote. If the power of the numerator is the same as the power of the denominator, if the highest power are the same in each, then your horizontal asymptote is the coefficients of the highest powers in the numerator and denominator, if they're the same power. Okay? So if these two are the same power of x, then you use the coefficients of those numbers to find your horizontal asymptote. If the numerator is smaller than the denominator, the numerator power is smaller than the denominator, then your horizontal asymptote is at x equals 0. I should have x equals here. Okay. And if your power in the numerator is bigger than your power in the denominator, you have no horizontal asymptote. It does not exist. There are no horizontal asymptotes. Now, in this problem, right here, what's the highest power in the numerator? X to the what power? First. What's the highest power in the denominator? X to the first. So if they're both x to the first, we take the coefficients of both. 4 over 1. What's 4 divided by 1? 4. Birschbacher. Oh, I'm doing so bad today. I'm not going to teach after lunch. I'm just not going to teach after lunch. I'm just going to let you guys do work after lunch because can't teach. It's y equals for horizontal asymptotes because a horizontal line is y equals. Okay? So 1, 2, 3, 4 up. Horizontal asymptote. So your function is going to look like this. Okay? That function is going to look like that. Okay. This one, what's its vertical asymptote going to be looking at this? What's the vertical asymptote going to be? What will make that denominator equal to 0? When x equals 7. Now, they're both x to the first, so you use the coefficients. 1 over negative 1 is negative 1. Horizontal asymptote is negative 1. Number 7. Vertical asymptote here. To find the vertical asymptote, we have to factor that by difference of squares. Okay? X and x, plus and minus. What are the factors of 1? 1 and negative 1. So x plus 1 equals 0. So x equals negative 1. And x minus 1 equals 0, so x equals 1. So it's asymptotes. It has 2 vertical asymptotes. So it would look like this. We'd have a vertical asymptote here and a vertical asymptote here. Okay? Horizontal asymptotes. What do we see about x squared and x squared? What are their coefficients equal to? They're equal to 1. They're both the second power, so their coefficients are 1 and 1. So it would look like this. And so the graph would look like this. like this down here, and in between it would look like this. And you say, hey, it crossed the horizontal asymptote. It's not supposed to do that. You can cross a horizontal asymptote. You can never, ever cross a vertical asymptote. Lines, functions can cross a horizontal asymptote, but they can never cross a vertical asymptote. So that's what they look like. All right. So here we go. After my horrible teaching today, what I'm going to do is I'm going to assign